welcome to Monday's edition of 6.2 Part 2 Notes. The first thing we need to do today is review something you should have learned in a previous class about special right triangles. There's two different types of special right triangles that we will be using. One of them is a 45-45-90 triangle. This triangle comes from cutting a square in half. A square starts with all 90-degree angles, and then if you cut it diagonally, you're breaking those 90-degree angles here into 45-degree angles, so that we have a 90, 45, and 45 totaling 180. The sides of the square are all the same exact length. So, say for example, we have a square that has 1-inch sides. This would be an inch, this would be an inch, this would be an inch, and this would be an inch. But this length here will be longer than an inch, and we can find that value by using Pythagorean Theorem. We can do 1 squared plus 1 squared, and that's going to be equal to our hypotenuse squared. So 1 squared plus 1 squared is 2, but that's giving us the value squared. Well, let's just call it c. So if we actually are trying to find c, we then have to square root that value, and we get the square root of 2. This will work out with any number regardless of what length the side of the square is. It will turn out so that if the sides of the square are some other number n, then the diagonal is n times the square root of 2. Let's say, for example, that n equals 10. If that side equals 10, then this side also equals 10, because remember this is a square cut in half, or an isosceles right triangle, which means those two legs are congruent. Well, if both of the legs are 10, then the hypotenuse is 10 square root 2. It's just a little shortcut we can use, since that will always happen when we use Pythagorean Theorem. Let's apply this to a triangle whose sides we don't know. Instead, maybe we just know the hypotenuse. So in this case, let's say we have a triangle with a hypotenuse of 1, and we don't know what these two sides are. Well, in this case, we need to work backwards. Instead of taking our number, like 10, and multiplying by the square root of 2, we take this number, which is 1, and we divide by the square root of 2. So 1 divided by the square root of 2, to go backwards to the lengths of the legs instead, can also be written as 1 over the square root of 2. And if you remember anything about rationalizing roots, rationalizing the denominator, we have to multiply the top and the bottom by the square root of 2, which gives us the answer square root of 2 over 2. That will be the length for this side here and this side here. Now let's talk about another type of special right triangle called a 30-60-90 triangle. 30-60-90 triangle can be thought of as coming from an equilateral triangle and splitting it in half straight down the middle. In an equilateral triangle, all of the angles are 60 and all of the sides are the same. So if we split that in half, then this little piece is half of what it once was, which means it's going to be half of this, because remember how we started out with all of those being the same length? So if this is a length of 2, for example, then this one would be 1. Then if we want to find this other side, we can use Pythagorean Theorem again to find it. So again, I start out with a squared plus b squared equals c squared. This time I know one of the legs and I know the hypotenuse, and I'm trying to find the other leg. So let's plug this number in for one of the legs. And let's plug this number in for the hypotenuse. 1 squared is 1. 2 squared is 4. Subtract the 1 from each side, so b squared equals 3. And that means that b is the square root of 3. That's where the answer for this other leg here in our 30-60-90 triangle comes from. In general, if the size of our triangle is different, so in other words, if the hypotenuse was some value of n doubled, that means that the short leg of our triangle would just be n, because it's half of this. and then the long leg of our triangle would be that value, n times the square root of 3. It's going to work out with Pythagorean Theorem no matter what number you use for n, and therefore we can use this shortcut to figure that out. Let's say we have a 30, 60, 90 triangle whose hypotenuse happens to be 1. How would we find the other two sides? I'm going to call this x, and then of course once I find x, this will be x square root 3. So let's go ahead and work backwards. This side is always half of that one. So if this is a 1, half of 1 is 1/2. So if x equals 1/2 for the short leg, because the hypotenuse is 1, then the long leg will be 1/2 times the square root of 3. A better way of writing that is square root of 3 over 2.